Well, hello guys. This is the Edpuzzle notes for Module 6, Lesson 1, adding and subtracting polynomials. Our learning target today is that we will be able to add and subtract polynomials in function notation. It's going to look a little something like this a little bit later on. In about 20 minutes, we're going to be able to do that together. I have been interrupted on this Edpuzzle about 13 times, so I've already filled in notes from the last time I tried to record, so I'm just going to walk through it as you guys can write this with you, or hopefully you guys were able to print this out. So here we go. So there's some common vocabulary that we're going to be using over the next module. And so if there are any terms here that don't look familiar to you or that you think that you should have a better understanding of, be sure to look those up. I've put some of the more important ones here on the side: terms, polynomials, standard form, and like terms. Looking at polynomials, by definition, they are math expressions consisting of many terms. This is a math expression consisting of many terms. And in order to know what that means, you have to understand what a term is. And a term is simply an expression that is made up of a number and a variable. No, that's not a hashtag. A number and a variable means that each of these are terms. We have the number, and we have a variable and its exponent. So in this polynomial, there are 1, 2, 3, 4 different terms. You'll know which term, you'll know how many terms there are because there will be an addition or a subtraction sign between each one. So some examples are a monomial, because it begins with M-O-N-O, mono, meaning one term, can look a few different ways. And so I have some examples. I have the number 8, 6y squared, 2x squared, y, z to the third. Obviously, the possibilities are endless, correct? But there are no signs separating terms, so we know that there's just one term there. Binomials you have already worked a lot with. We have x squared minus 4 and 3y plus 4xy are just a couple examples separated by one sign, so we know that there's two terms there. Trinomials, this is a perfect square trinomial you guys know quite a bit about already, and there are 3 terms in this one, tri meaning 3. And in this one, we have just a made-up negative 3x y to the 4th minus y cubed plus 2. It doesn't have to make sense or factor to anything. It just has to have 3 terms. And polynomials actually refers to all of these, including monomials. Polynomials, most of the time, are used to describe math expressions that have 2 or more, but really it means all of them. And so I just put an arrow showing that, yes, it means this. Yes, it means all of these. These are just specific types of polynomials. And then I also wanted you guys to see that there are also some non-examples. So in case you came across different ideas, you knew which were and which were not. So some non-examples are, if your exponent is a negative, you cannot have a negative exponent. You cannot have a variable and an exponent in the denominator. You cannot have the simplified variable in a radical form. And although this can technically go up as high as numbers go, you can have as many terms in a polynomial. It has to be finite. So it can't go on forever and ever. It has to be a finite number of terms. So you can't have an infinite or infinity number of terms. Other than that, chances are you're probably working with polynomials. And we today are going to learn all the rules behind adding and subtracting those polynomials. So when we're adding polynomials, lucky for you, you guys are already well versed in all the laws of algebra. We are going to take all our principles of algebra and we're going to apply it to these functions, or these polynomials. So I've written a polynomial here, and this is where I got cut off last time. We are going to add these polynomials by combining like terms. Well, in order to combine like terms, you must understand what like terms are. It means that they're terms whose variables and their exponents are the same. So yes, the variables here are all the same, x, 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 but their exponents are not. So here we have x squared, and it means that I can only combine these with other terms that have x squared as their only part of their variable. Can't be x squared, y, it has to be just x squared. So if those match up, you're able to add them like we have here and here. And those variables are going to stay the same. And you are just simply going to add the coefficients. So the 4 and the 6, you're going to add just like normal algebra. 4 plus 6 is 10. So I'm going to show you two ways to solve this equation. So the vertical method means just like when you were, in elementary school, that you took the two numbers that you were adding and you put them on top of each other and you lined up your ones columns and you lined up your tens columns and so forth. We're going to do the same thing, only there's a very special order that you have to put it in. And that's called standard form. In my example up here, I have already put this polynomial into standard form. Standard form means that you're looking at the degree of the variable, and you're putting it in descending order. So the first term that you're going to put in your polynomial needs to be the highest number of exponents. So this has a degree of 3, so that's going to be my first term. I put the second because it has a 2 degree. This one has a degree of 1, even though it's not written in there. We know it's an x to the first. And even when you have a number that has no visible exponent, technically speaking, it is x to the 0th power. We call this a constant because it has no visible variable, and the constant always goes last. So I'm going to rewrite my first polynomial in standard form. So I'm going to look at all of my degrees, and I see that 5x to the 4th is my largest. So I'm going to put 5x to the 4th as my first term, and I'm going to keep going in order. Minus x to the 3rd. I'm going to add 4x squared. My next term should be an x, but I don't have any of those, which is fine. But I am going to put a placeholder in there. And this should look familiar to a lot of integrated 2 stuff that you guys did last year. And I'm going to add 2. That's my constant. And now I'm going to take, since I'm adding the second polynomial, I'm going to add these, but I need to make sure that I am I'm aligning the like terms. So my other x to the 4th, I'm going to put right under the 5x to the 4th. So in this polynomial, I have 3x to the 4th. That I'm going to place right underneath. I'm going to put my x to the 3rd underneath, but there isn't one, so I'm going to use a placeholder of 0 plus 6x squared minus x is the same as minus 1x. I'm going to put minus 1 just so I add correctly. It kind of clears things up for me. And I have no constant term, so I'm going to put plus 0 as a placeholder. And the reason we put placeholders is so we don't accidentally align the incorrect terms with one another. And now I'm just going to add this normally. So when you're adding variables with exponents, you treat them like you're saying 5 apples plus 3 apples equals 8 apples. It doesn't change your variable at all here. You're just going to combine the coefficients. So 5 plus 3 equals 8, which gives me 8x to the 4th. Negative 1 and 0 is going to be minus x cubed. It's the simplest way to write that. 4 plus 6 be plus 10x squared minus x plus 2. I'm sorry if I'm rushing you guys. I want to make sure this video doesn't get too long for you. So that's vertically how you would solve it. And I put the instructions here, kind of the step-by-step of what you would do for that. The other way, which I have just called grouping, some people call it horizontal, one's vertical, one's horizontal, is that you are going to visibly look to see which like terms you have, and you are going to group them here. Now, if they're large numbers, you're going to want to write them out together, maybe put them in the parentheses together. But if you're using numbers that you can use mental math on, it's not really necessary. But I'm going to show you what I do to make sure that I don't forget any of the terms and get the wrong solution, which can happen really easily. So I'm going to write this again in standard form, only when I look to combining, I'm going to start with the variable I'm supposed to, x to the 4th, and I'm going to look for x to the 4th over here, and I'm going to circle them both. Okay, I found both of them. I found all of the x to the 4th. And I have a positive 5 and a positive 8, and I can do mental math to find out that that equals 8x to the 4th. Now, when I'm done with it, I cross it out. So I can say, okay, I know I already used that. I already know I already incorporated it and added them together. Okay, so now I need to do x cubed. So I know I have an x cubed over here. And I don't have one over here, so there's nothing to add together there. So I'm just going to write it as is, so minus x cubed. Now I'm going to move on to x squared. So I have 4x squared over here, and I have 6x squared over here. When I add them together, 4 plus 6 gives me 10x squared. Now I'm looking for just x, and I only have one of those terms. And so I'm going to simply write minus x down here, cross it out because I know I used it. And I have one constant, which is plus 2. And I'm going to cross it out and use it. Now, if you compare my two answers, I have the exact same answer. 8x to the 4th plus x to the 3rd plus 10x squared minus x plus 2. Whichever way you would like to do it and organize your thoughts, however your brain sees this problem, do it that way. I'm going to give you a practice problem, and then we're going to try substituting polynomials. All right, hopefully, I'm pretty sure that didn't give you too much trouble, but perhaps you're starting to see where you might run into some problems. How you could very easily forget a placeholder or go a little bit too quickly through this. But if you take your time, I'm certain that this is something all you guys are very capable of doing. Subtracting gets a little bit more complicated, but the steps are the same. So if we're solving vertically, what I need to make sure is nothing is going to change with my beginning, with my first polynomial. I'm going to write it in standard form. I'm going to make sure I go in descending order where my first term that I write down here is my largest term. So I have 5x to the 4th minus 9x cubed minus 3x squared plus 4. Oh, excuse me, plus 0x. See, I almost forgot my placeholder. Plus 4. What changes in subtraction is that we are now subtracting this entire quantity. So no longer are we just adding and we're combining like terms, but since we are subtracting, you can look at it a few different ways. You can see it as we are doing the opposite. We can see that I like to see it as like we're distributing a -1 to each of the terms. But what this means is that we do want to eventually add. So we are going to change the signs. We're going to distribute this negative to each of the signs all the way across. And then once we have those new numbers, we're going to put them down here. And then we're going to add. Okay, so instead of -2x, since we're doing the opposite, now we're now adding that, it's going to be +2x. And I'm going to go ahead and change these signs before I bring them down here. Instead of positive x squared, it's going to be -x squared. Instead of +11, it's going to be -11. And instead of positive 4x to the 4th, it's going to be -x to the 4th. And so once I've changed the signs, I'm no longer subtracting. Now I'm adding the opposite. So I'm going to put -4x to the 4th right here. My x cubed, I don't have one, so I'm going to put plus 0x cubed. My x squared is a negative x squared, or -1x squared, if you rather. My x value is a +2x, so I'm going to put plus 2x. And I don't see, oh, I do have a constant. -11 is my last term. And so the only thing that we did differently is that we had to change the signs, and then we're going to add like normal. So 5 minus 4 gives me 1x to the 4th. I don't need to write the 1. That's not its simplest term. I'm just going to write x to the 4th. -9 and a 0 gives me 9x cubed. -3 and -1 gives me -4x squared. 2 plus 0 is 2x. And +4 and -11 is -7. Again, if I'm talking way too fast, you guys can always pause it and take a double check at what you're doing and check your work. I'm going to show you how to combine like terms mentally and then to put them in standard order here standard form here. So I'm going to start again with x to the fourth. Those are my largest terms in each one. I would have had to change the signs anyway. So that first step of changing the signs here is the same for both methods. You want to make it sure that it's addition that you're doing and that you are changing the signs. So I'm going to start with circling my 5x to the fourth and negative 4x to the fourth. And I can do that mentally. 5 minus 4 gives me 1. 1x squared, 1x to the fourth will just be x to the fourth. I've used both of those, so I'm going to cross them out. Now I'm going to go to x cubed. So I have negative 9x cubed here. I'm just continuing to go in descending order. I don't have an x cubed here, so I'm just simply going to write that as is. Minus 9x cubed. Now looking for all of my x squared terms. I have a negative 3x squared here and a negative x squared here. And when I combine negative 3 and negative 1 can be assumed is right there. That is going to give me negative 4x squared. Cross those out now that I've used them. I'm now looking for all of my x terms. Plus 2x is all I have. So I'm going to cross that out, make sure that it is accounted for. And then I'm looking for all of my constants, which is a positive 4 and a negative 11. When I combine those together, it gives me negative 7. And if you'll see, two different methods give you the exact same polynomial for a solution. I'm going to give you a practice problem to try on your own, and then we're going to come back and try function notation. Emphasis on the fun. All right, our last section here, I hope won't give you too much trouble. It looks scarier than it actually is, you guys. So what we're just getting used to is we are going to add polynomials and subtract polynomials just like you did here. Nothing's going to change on the math part. What is going to change is the notation. So we're going to get used to seeing what it looks like when we add functions and when we subtract functions. Take, for example, we have the function f of x equals 2x plus 1. And we have a second function, g of x equals x squared minus 4x. We are going to add these two functions. However, you cannot add f of x plus g of x because these have no place in algebra. They don't mean anything to us. They don't follow any rules. But we can substitute their values in their place and then add our polynomials like normal. So in place of f of x, I'm going to put 2x plus 1. And anytime you're substituting, you really should put parentheses on it. Even though it's not going to change our solution in this particular case, it's still a great habit to have. So anytime you're substituting an expression for a function, you're best off putting parentheses in so you don't make any mistakes, especially when we get into subtraction here in a minute. I'm going to do the same thing for g of x. Instead of g of x, I'm going to add x squared minus 4x. So plus x squared minus 4x. I'm now going to combine like terms. I like that second method. I like being able to do it in my head. If there's not too many numbers to keep up there, then I'm just going to do it there. I'm going to do it in standard order. So I'm going to start with x squared. It is the only x squared, so I have nothing to add it to. I have 2x and negative 4x. That when combined or added together will give me negative 2x. And the last term I have is a constant term of plus 1. So I don't know if you can see that through the dotted line, but my solution is x squared minus 2x plus 1. We're going to do the same problem, only this time we're going to subtract. So if we subtracted f of x minus g of x, looking at that, it might look like a difficult problem, but we know that we are not dealing with functions when we're doing this problem. We are merely substituting one in for the other. So f of x equals 2x plus 1, so that means I can substitute 2x plus 1 in its place. It's going to be important to put your parentheses in this time because we're going to have to distribute this negative to the entire binomial x squared minus 4x. So we are going to subtract x squared minus 4x. Now, before I can combine like terms, I'm going to have to distribute this negative or do the opposite all the way through. So that subtraction sign is going to become a positive. Positive x squared is going to become negative x squared. I wish I could rewrite it again because I know that's hard to see. And negative 4x becomes positive 4x. Now that I have distributed my negative throughout this entire binomial, I'm now able to combine like terms. So I have now negative x squared. I'm going to combine 2x and positive 4x this time, which will give me a positive 6x. And my last term, my constant, is plus 1. So some ways that you're going to see this function look, or this notation look, is when you're adding, it might look like that. It might look like f of x plus g of x. You might see it written this way as well, though, which might look a little bit different to you. F plus g and then x. Those mean the exact same thing. Those both mean, yep, we're adding. In the same sense, you're going to be subtracting, and your notation might look the same way. It might look like f of x minus the function g of x, but it might also look like f minus g and then x on the outside. Both notations are going to be presented to you. Make sure that you're comfortable with both. So we're going to try this problem first. G of x equals 3x plus 1. F of x equals x squared minus 5. G plus f, we see that new notation, times x. G plus f, so we're going to rewrite our equation not in function notation, but actually in algebraic notation. So my g of x is going to go first. I have 3x plus 1. And I'm going to add the f of x, which is x squared minus 5. And now that I have it set up all together, I'm just going to simply combine like terms. X squared, done, plus 3x. There are no other terms to combine 3x with. And plus 1 and negative 5 will be my last term. And that gives me a negative 4. I will write my solution as, the way it was given to me, g plus f of x equals x squared plus 3x minus 4. Let's try it again with subtraction. As you can see, the notation is a little bit different. They did f, the function of n, or f of n minus g of n. And so we need to substitute n squared plus 2 for where we have f of n. So n squared plus 2 minus g of n, which is 4n minus 3. So before I can combine and add like terms, I have to change my signs all the way through. I'm going to distribute the negative. So I'm going to add a negative 4n and a positive 3. Once I've done that, I can combine like terms, and I get n squared, done there. I only have one n term, so minus 4n, nothing to combine. And my last term would be to combine and add positive 2 and positive 3 together, which gives me plus 5. Every term has been accounted for, so I am done solving. And so your solution would be f of n minus g of n equals, that's me being lazy and not wanting to write this out one more time. That would be your solution. All right, the last way you're going to see this problem, make sure you guys can see the bottom right there. Last way you're going to see this problem is, if you'll notice this time through, it doesn't say x anymore. We actually have a value for x now. They want us to add these two functions together, f of x plus g of x. And once we come up with a solution like we did here, we're going to then give that x a value of -3. So everywhere you see x, you're going to plug in -3 instead. So when we get to the end and we do f plus g and we plug in -3 as our input for x, we will have an actual solution. We'll have an actual number answer, an output. So let's give it a try. Last problem, and then I'm going to leave you on your own to try your homework and give a few of these problems a chance yourself. So f plus g, I'm going to start with f of x, which is 2x plus 5, and g of x, which is 2x minus 3. I'm going to combine like terms. Since we're adding, I have nothing to distribute. It's just the terms as they are. And my greatest term is 2x. And so when I combine 2x and 2x, it gives me 4x. And I'm going to combine my constants, plus 5 and a -3. 5 minus 3 would give me positive 2. I don't know why that took me so long. So now that I have the most simplified binomial as a solution of me adding the function of x and g of x, now that I have this, I'm going to substitute -3 in for x, and it's going to give me the solution for this problem. So once you get to this last step, the same way we've done all the way through here, you're simply going to actually solve by plugging in -3 as our input. So I'm going to rewrite the equation or the expression as 4 times, instead of x, I'm putting -3 plus 2, and I'm going to solve. I'm going to take care of the parentheses first. 4 times -3 is -12, plus 2 is -10. And so if they're asking you to find the function of f and g when our input is -3, our output is -10. Our solution is -10. All right, so I'm going to give you a couple problems to try like this, one to try like this, and on your homework you will have a bunch of samples of each. If I went too fast, I'm sorry. I'm a fast talker, and I wanted to make sure you got through this quickly and got onto your homework. So if you have any questions, you know how to find me in my office hours. Good luck, and I will see you on the next video.